4 is called a non-square system of 3 equations, meaning that we have 3 unknowns, but we don't have 3 equations. So it's like, if you imagine 3 unknowns, 3 equations, 3 by 3, that's like a square. Non-square meaning that we don't have enough equations to match. One of two things is possible here. These two things represent planes. Those planes either intersect in a line or they're parallel to one another. If they're parallel, the answer is the empty set. If they meet at some line, there's going to be C answers like we've gotten C answers before on this problem. So first thing we want to do here is we want to get rid of a variable. Doesn't matter which one we get rid of. To me, Z looks really easy to get rid of since they're already opposite. So if I go ahead and add the two equations together in their current state, x plus 2x makes 3x, negative 2y minus y is negative 3y, and 3 plus 15 is equal to 18. That gets me down, if I divide by 3, to x minus y is equal to 6. As long as that comes out to something with variables in it, you're going to be looking at a C answer. If it comes out to 0 equals 2 or 0 equals 1/2 or anything like that, then you're looking at parallel planes. The answer is the empty set. And both scenarios happen on the homework. I'm only showing you one where it goes beyond the empty set. So when you get to x minus y is equal to 6, you're at a point where you're going to get a C solution. So an ordered triple, each one of the numbers in the ordered triple is going to represent some version of C. You have to make up an answer to begin with that is C, either x or y, because we've already gotten rid of Z. So do we want x equals C or y equals C? Doesn't matter what x. All right. So if x equals C. All right. So that means we're going to put C in the first position there. And I want to go ahead and find out what y equals based on this equation. So I go back to this equation. I take the fact that x is equal to C. So C minus y is equal to 6. I want to get what y equals in relation to C. I move the 6 to the left and the y to the right. I get C minus 6 is equal to y. So y is C minus 6. It wants to know both x and y in terms of C. I want to change x and y to their C expressions, and I want to figure out what z equals in terms of C. So that's going to get me 2z, or hold on, getting ahead of myself there. X, which is C, minus 2y, and I'm replacing y with C minus 6, so parentheses replacing one object with multiple objects, parentheses always get used, plus 2z is equal to 3. A little distributive property here, make sure that's a negative 2 distributing, so it's going to be C minus 2c plus 12 plus 2z is equal to 3. My job is to figure out the value of z in terms of C, so I want to get z by itself, everything that isn't z to the other side. Let's move the 12 over is minus 12. C minus 2c altogether makes negative c. Moves over is a positive c. So I end up with 2z is equal to c minus 9. Divide both sides by 2. Z is equal to c minus 9 over 2. Keep in mind that if the book did it a different way, they're going to get a different looking answer that's going to represent the same thing. If you want to make sure your answer is right, it's real simple. Pick some off the wall number. Don't pick 0, 1, or negative 1. Pick something like 23 or 44 or something like that. If I have a fractional structure, though, I'm going to go with something that's going to make this a non-fraction. I prefer substituting in non-fractions personally. So I'm going to pick, if I pick an odd number minus 9, it's going to be even, right? Divided by 2 divides evenly. So let's pick some weird odd number. Tyler, go. A weird odd number. 21. 21, perfect. Okay, so Tyler's letting C equal 21. So if we consider whether or not that's the right answer. So if Tyler's letting C equal 21, 21 minus 6 is 15. 21 minus 9 is 12 divided by 2 is 6. That's just some random ordered triple that we can create based on that structure, right? If this is the right answer with our random, now this isn't mathematically rigorous, this isn't valid mathematically or whatever, but it's a pretty safe bet if you can just randomly pick some weird number off the top of your head, throw it in there and get an ordered triple. If this ordered triple makes both those equations true, it's the right answer. right? So all we have to do is verify that if we put that ordered triple right there, numerical, into both of these equations, we get true statements. So let's try it out. X is 21, minus 2, y, that'll be minus 30, right? Plus 6 is supposed to equal 3, and that's not right, is it?
It's 12. 2z.
Oh, 2, thank you. I was going to say, my theory is wrong. I don't like that. So plus 12. It helps to actually evaluate things correctly when you're doing this check too. But anyway, 21 minus 30 plus, so 21 plus 12 is 33 minus 30 makes 3. Okay. And if I try the same order triple in the bottom one, 2 times 21 is 42. Minus y will be minus 15. Minus 2z is going to be minus 12. It's supposed to equal 15. 42 minus 15 is 27 minus 12 equals 15. Also true. Both equations are true. That answer is right based on this answer, so I can be pretty much sure that answer is right. So that's an easy way to verify. Also, I mean, if you get an order triple from this and kind of compare it to the book's order triple, if they do a different way of doing it, you can verify it that way also.